Hello and welcome to GCSE Physics Revision. This lesson is about speed, distance and time. It's probably the simplest of all the motion equations, and you've probably seen it somewhere further down your school career. Okay, that it basically states that the average speed, and that's an important thing, it's the average speed of any object is equal to the distance it travels divided by the time it takes to get there. Okay, so average speed equals distance divided by time. Now, if you're not a fan of maths, that can be written as one of these maths triangles that you have three subjects here, here and here, and then you would have that down here you have speed, up here you have distance, and down there you have time. And how these work, if you cover up one of these objects, then what remains is how you calculate the hidden one. So let's get myself a little square and fill it in just to remind you how these work. So if I want to find the speed, I cover up speed, and that leaves me with distance divided by time, like here. If I want to find time, it is distance divided by speed. If I want to find distance, it is speed multiplied by time, because they're beside each other. It's like rules of algebra. So that's ST. Okay, so moving on then. Average speed usually measured in meters per second. Okay, but it depends on what you measure your distance and time in. Okay, if you're getting your average speed in meters per second, then your distance should be in meters and your time should be in seconds. If you want it in, for example, kilometers per hour, then your distance should be logically in kilometers and your time should be in hours. Watch out for this in exams. They tend to mess you around with this, that you get given distances in kilometers and asked to get the average speed in meters per second. In that case, you have to convert from kilometers into meters, and that's generally done by multiplying by 1,000. Not generally done, it's always done by multiplying by 1,000. Okay? If you're not sure whether to multiply or divide, you do a simple test case in your head. 1 kilometer is 1,000 meters. So to get from 1 to 1,000, I have to multiply by 1,000. Okay, it makes sense that you're going to have more meters than you're going to have kilometers. Okay, now that's not the difficult bit of this. This is pretty straightforward in terms of the equation and moving it around. The difficult part comes generally with the graph work. Okay, people aren't happy about graphs. Graphs scare people. Graphs freak people out. I'm not entirely sure why. They just do. Okay, so let's take a standard graph. Okay, it's got a couple of little sections in it. We have time across the bottom, and we have distance travelled up the side. Okay, so we should have some units there, so that's in meters, and this is in seconds. Okay, now standard question would be something along the lines of calculate the average speed between parts A and B. Okay, if this is point A down at the bottom, very start, and then up here we've got point B, and then a little bit further on this would be point C, and then this would be point D up there. Okay, so average speed between points A and B. So what we want to do is we want to read off the distance that I travel between A and B. Okay, so the distance traveled between A and B is that. Okay, whatever the distance in your, or whatever the difference in your axes is, okay, between that point, that's your distance traveled, and the time taken is how long it takes to get across from there to there. Okay, and I read down to my graph like that. Once I know the distance that I travel up the side here and the time it takes me, then I use average speed equals distance over time. Okay, that would be a rather easy example, and you'd be delighted if you got that. More common ones are you get things like calculate the average speed between B and D. That's how I'd set the question. It gets the casual reader, the person that doesn't have a clue what they're doing. Okay, so what you do is you go to B and you do your dotted lines across the axis so that you can read off your stuff. You go to D as well and read off your information. Okay, now remember, this time the distance traveled is the distance between where you started and where you end up. So it's that distance there. Okay, so you're going to have to take the top number away from the bottom number. The time it takes you is the time from there to there. So again, there's a subtraction to be done. Okay, this is my distance traveled, if I could spell it. and this is my time taken. Okay, normally you would see distance travelled questions done as a couple of parts. Find the average speed between A and B, find the average speed between B and C, find the average speed for the whole journey. Okay, these become a little bit more complicated when we get velocities and so forth, where the graph can come back down again, but when it's speed, distance and time, it remains quite simple. Read off the graph. Once again, general fact of any form of graph, first thing you do is when you see a graph, you see what's on the axis. So I have distance and time. So if I'm being asked, it's distance over time. Okay. The complicated way of saying that is that the average speed is the gradient of that graph. Okay, that is the change in the y-axis divided by the change in the x-axis. But for a formula as simple as average speed, just read off the numbers. Okay. But since it is the gradient, we should be aware of the fact that steeper lines mean faster speeds. Okay, so steeper lines mean faster speeds, and horizontal lines mean, because it has no gradient, mean no speed, so it's stationary. Okay, first one done. Easy peasy on motion.